To begin our discussing of integral calculus, we'll talk about antiderivatives. Capital F of x is the antiderivative of f of x on an interval L if the derivative of capital X equals f of x for all x in the interval. So let's just say we have an f of x, a simple f of x like 2x. Well, one possible capital F of x would be x squared. In fact, this would work for all real numbers. The derivative of x squared is 2x. But notice we could make another choice. We could choose x squared plus 5, for example. And of course, the derivative of 5 would be 0, so the derivative of x squared plus 5 is also 2x. And in fact, we could add or subtract any number we wanted and still get the same derivative. And so what this means is the most general form of the antiderivative is x squared plus c, and c is known as an arbitrary constant. And anytime we find a general antiderivative, we're going to have to include an arbitrary constant because, of course, when you take a derivative, any constant would vanish. It would become 0, so we'd never know what constant would be there. And often it actually turns out in various applications there'll be other conditions which determine the arbitrary constant. So mostly finding the antiderivative is just a matter of following the derivative rules backwards. So for example, if f of x equals x cubed, well, we'd like to know what the antiderivative of that would be. Well, we suspect it would be something involving x to the fourth. We know that if we just take the derivative of y equals x to the fourth, what we get is 4x cubed. And we don't want that 4, so we need to multiply by a factor that cancels it. So we multiply by a quarter. Then, for example, capital F of x could be 1/4 x to the fourth. And notice that if we took a derivative of this, what we would get is 4 over 4 x cubed, or just x cubed by itself. So that is the antiderivative. And of course, we'll need a plus c there. If f of x equals sine x, well, we might ask what has a derivative of sine x. We may remember that the derivative of cosine is negative sine x, so we need to toss in a negative sign. So if we take a derivative of negative cosine, we will get a positive sign. And so there the antiderivative, general antiderivative, is negative cosine plus c. So this is just an introduction to the idea of antiderivatives, and I'll show an application in the next video.